Hello guys, I hope you're doing good. So welcome to this tutorial. In this tutorial, we are going to learn about thread dump analysis from scratch. So first we'll look out. We first will see the how to create a program and how to analyze this thread, and then we'll create a thread dump and then analyze it using different tool. And during this exercise, we'll learn about the basic terminology which is used in the while analyzing the thread dump. And in the second video, we will see how to use this our understanding, and I'll give you some real world example where you will apply this kind of knowledge, and then we'll try to find out the root cause. So, yep, so let's get started. So, as I said, so first I will show you some code example where I will try to create a different thread lock situation. First will be a deadlock where I will create a deadlock kind of situation, and there will be another program where we'll see the different way of create different program where it is waiting for some different thread kind of concept. So what this tutorial does not cover is basic understanding of different Java thread, how it is working, and also how the JVM works. So I hope you can find my other tutorial to go through that, or some other Google resources also you can look around. So let's get started first. Yep, I will just close this program. Yep. So first I have written this code, and yeah, this code will be available to you for play around this, so don't worry. I'll just post it at the end of this video. So what is I'm doing in this program is basically I'm trying to create a deadlock. So I have a resource A and resource B, and as you can imagine that a deadlock means that when resource A is trying to acquire a lock on resource B, and resource B again trying to acquire a lock on resource A. So let's see what is there in resource A. This is just a simple class similar to resource B. So in real world example, it will not be like this. In real world example, you will try to do some kind of network, either network operation or some calculation. You will be doing it, or you can maintain some session which you need for some maybe some user maintaining some user session in the application, or you'll be querying some database. So many things can be possible while in this resource A and resource B. To keep these examples simple and to make our understanding pretty clear, so I have just created a simple code for it. So here what I am doing here is a thread. This is the first thread and this is the second thread, and I'm just starting in the interval, or in first starting it to first thread and second thread. So and it is this thread is I have a runnable interface implemented, and here I have a synchronized block where I'm trying to acquire log the resource. So print the resource, and it is just printing it. So let's run this code, and let's see what it's doing here. So here resource A and resource B, and here is thread 0. It's trying to log the resource first resource A, and in second thread it logged the resource B. So now it is a kind of a deadlock situation. So now I will show you one tool, basically two tools which I'm using for creating this thread dump. So first thing, my favorite is a VisualVM tool. So let me close this thing. Yeah, yep. So so here my program is this deadlock 26908. So it has already automatically detected this code, and let me double click on it and then go here, and then if I open it and go to the thread section, yeah, you can see here it has already detected the problem here which is there. So now here also we can create the thread dump like multiple times. Yep. So one thing you have to keep in mind that when creating the thread dump, we have to create multiple thread dumps, because single thread dump does not give the complete picture of each and every thread. So I can go ahead and create multiple thread dumps here. thread 2 and thread 2, thread dumps. Yep. And as you see here, it's already thread detected. So it's pretty straightforward. But in real world example, you might get this deadlock detected and might not get, because not every thread dump, every threads in real world example, not every uh, the thread dump that we analyze, it don't have to deadlock, be into a deadlock situation. But still, we have to find it out our way of go to the root cause. So the main idea behind this tutorial, this program, is to understand the different terminology. So one terminology we'll see here as I created, like waiting on condition, and also what is waiting for entry, monitor entry. So this thing we have to be clear our understanding. So what does it mean by waiting for monitor entry? So for that, I have written it here. So waiting for monitor entry means, it means to wait to lock an object, since some other thread may be holding the lock, and which can happen in a synchronized code. So what does it mean? It means that here you can see here, uh, uh, wait to lock an object since some other thread may be holding the lock. It is waiting to lock an object, as you can see, and meanwhile some that is happening in synchronized code. So here I have a synchronized code here. So resource, it is first resource is synchronized and under the synchronized block, and then it is uh, wait to lock an object. So this first resource A is trying to lock an object resource B, right? So that is what it means. It means waiting to lock an object and while holding the lock, and that is always happening in synchronized code. So all these things you can see here, it is happening in this block of code. So now, as we saw here that this we create this thread dump from here. There is another way of creating the thread dump, that is called jstack. So what is the difference between jstack and VisualVM is that you have to download VisualVM, and it is a visual, it gives the kind of UI. But in Jest, and you have to download it specifically. It does not come as part of JDK. But whereas jstack, it comes as part of JDK, and you can just use it using the PID. So first, let me bring that jstack here. So let me clear the console here. Yeah. So uh, how we can use the jstack tool? It is a command line based tool. So here I have to I'll just remove this thing. It is a command, jstack command, and here I have to put this thing here, and we have to find it out the PID of this program. So if you are on using if you are using uh, a Windows machine, then you can just go to Task Manager and then see the background process what is running here. And this is the one. This is for the Eclipse workspace, and this is the our Java program which is running. So here you can see 26908. This is the PID also, and here also the speed 26908. So now I am going to write 26908. This is the one thing. And this is the number two here. Yeah, as I said, I have to take the multiple thread dumps. I would recommend you to take while in real world example, when you have to analyze it, then you take at least 10 thread dump in the interval of, let's say, 15 seconds, so that it can gives you all these details about the thread. So here I have created three thread dumps, and this should be created here, thread dumps. Yeah. And also now we can I can open it in a notepad plus plus. I'm using notepad plus plus, and you can use any of your choice. So here you can see here waiting on condition, and here it's uh, uh, thread 0 waiting for monitor entry. So here as we can also, as we already discussed, that what is the monitor entry here, thread 0 is on waiting for monitor entry. And why it is waiting for monitor entry? Because it's waiting to lock this resource B, right? So resource A is waiting to lock resource B, and similarly thread 1 it is also waiting for monitor entry is because it's waiting to lock resource A. So again, what does it mean? It means it to wait to lock an object, right? So resource thread 0 is trying to lock an object on thread 1, that is resource which is resource B. So yep, so now I can also I hope you can see the screen correctly, or else I can copy this whole thing into my Node++ here, and let me save it. So I can also, let's say, test thread dump, test t dump dot log. So yeah, so now I will use the another tool that is called TDA, thread dump analysis. This tool is basically open source tool. Yep, and this open source tool you can also download it from internet. So this is useful. If you do not have any other you can use these different other tools. For example, fast thread IO is one of the popular tool, and also the JProfiler is another popular tool. But these are all uh, some paid version, so you have to have a license. But when you do not have a license and when you are learning some new stuff, then you can go ahead with this kind of tool. And actually this is a pretty nice tool, but in order to you if you want to use this tool, it you have to spend quite a good amount of time to understand it. But whereas if you are using some paid version of tool, then it will give you the some kind of problem state, which could be coming, but it does not the all the tool does not give you the accurate result, but it somewhere it gives the idea that where it could be the problem. Yep. So let's open this thing here in this dump file. So here we can see different kind of behavior here. So here it has already detected the deadlock here. Yeah, and then I just do this thing here so that, yeah, and then here it's this thing that's thread different kind of threads. Yeah, so here thread 0 and thread 1, which we saw in our program, which was there thread 0 here and thread 1. And apart from that, here also you see the many other threads, right? Finalizer, C2, compiler. So these are the thread which is handled by the CPU. There are some CPU thread and there is some VM thread. So these are the all threads which is out of the box, which is coming as part of JDK and a CPU thread virtual machine. So what is our point of concern is that thread 0 and thread 1, okay? So because we are creating it for one. So here, as we already saw, that it's waiting for monitor entry and it is block state. Yeah. And similarly, thread 1, it is also in block state. And why it is block state? Because it is waiting to lock. So one thing you have to keep in mind, that if it is blocked, that does not mean always that it is there's some problem. There could be some thread also where it is blocked, and then block can be released in some, let's say, 10 to 15 seconds. So it's waiting for something like a lock, but it does not get the resource. So but in some 10 to 15 seconds it can release it, and then the block can disappear. So if it is happening for multiple times, that is the reason we have to take multiple threads, and then we can see the different state of these threads and where it is blocked. So then we have to understand, okay, this thread is actually having a problem. So here it's thread 0, and here we see threads waiting for monitor. So as we saw, as we already explained, that thread 0 is waiting for monitor because it is waiting to lock this resource, and threads sleeping. So here it's all we do not have to worry about it. Yep. And here also waiting, just waiting with locking monitor. So again it is giving you the waiting for monitor entry here also, you can see. And Yeah, and here we can also, the monitors tab is basically gives you the idea about what is being which is being logged by this entry and what's the wait on monitor. Yeah, so logged by this thing is logged, waiting to log again and wait for monitor. So this is one way, this is the way how you can actually understand what is being logged here and what is waits on monitor. So waits on monitor. So we have seen that waits for monitor means uh, it's happening on the synchronized code. So there is something also called waiting on condition. So that we'll see in the next example what is that called waiting on condition. So, and wait on monitor also means that it sleeps or wait on an object specific period of time. So it is also waits for monitor, but it is blocked. So waits on monitor also it means that it sleep or wait on an object of a specific period until notified by another thread. This can happen when using reiterant lock, which we'll see in the next example. But before that, waiting on more conditions or waiting on monitor, it means that it sleep or wait an object and for a specific period of time until it's notified. So it is waiting on monitor here, but it is blocked. And that is the reason it is not able to release the lock. Okay, so that is why it is saying waiting on monitors. So I hope this is clear in this example. So now let's run another example. Let me stop this thing. So I have another code where I am using reiterant lock, and what is the difference between reiterant lock and the synchronized block is that reiterant lock you can use anywhere in your program, so you don't have to be in a class level or a function level. So you can try to lock this wherever you want within this function. And yeah, so uh, let me explain a little bit about this program, and again this program also will be available to you. This is an example of account transfer. So you can imagine that it is you are sending some money, and then it is and receiver is getting it. Yeah, and meanwhile it has to be, while doing the transfer, it has to acquire the lock, so that some other application is trying to debit that amount or credit that amount, then it should be synchronized. So that is the reason it is I have to lock and use a reiterant lock. And why I'm not using synchronized block is because I want to do this kind of logic before it tries to uh, acquire the lock. So it if I use synchronized, then it will not be useful to acquire the lock wherever I want. So that is the reason I'm using reiterant lock. Now let's run this code here, and yeah, and then meanwhile I can come to my Visual VM Studio and let me open it. Return lock, yeah, account transfer. This is the 26900. Yeah, and then I can create a I can here you see that here is no thread lock is decided locked deadlock is decided, sorry about that. So there is no deadlock decided, but we have to analyze this log. So let me create the thread dump as at least two thread dump I will create for the time being. And again, I will just copy this thread dump and then come to my string. And this time, let me save it as re in double reentrant lock. Um, los dump one dot log. So now I'll again use my TDA tool to open this log file here, and here again we'll see analyze the log. Okay, so again so let us go to this waiting on monitor threads waiting on monitors, and these are the thread here. So now you see here pull thread 1, pull thread 2, but this time it's not thread 0 and thread 1. Why? It's because we are using uh, 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 this uh, executor service here. So here though is it is using some thread pool. So if you also do not know about what is executor service, then I would highly recommend you to use do some your exercise, search in Google what is executor service is. So it's basically creates a thread pool, and where you can use this thread pool, and you do not have to manage all these threads by your own. So the executor service gives you the possibility to manage the all these threads by itself, by the JVM itself. You don't have to take care of closing the thread and all this stuff manually. So yep, so here I am transferring some balance from one account to account 2, account from. So now let us go to here, and here you see it is an waiting on condition. So what does it mean? Then also waiting on condition, and also here parking to wait for. Yeah. So also you have to notice this kind of abstract queue synchronization, so which will be useful to analyze while when I'll give you the real world example. So yeah, waiting on condition, what it means again, as we explained here, it means sleep on wait for a specific period or until it's notified by another thread. So it can happen using return lock. So as we saw here, it is already is happening. I'm using reiterant lock, and it is waiting to uh, waiting for the condition, to be fulfilled, and then it will be released. Yep. So this is what is happening here. And here you see thread pool executor. There is one service here logged by the RMI. So this is actually, as I was telling you, this is actually managed by the JVM. So these are the things which we do not have to worry at this moment now, because it is managed by JVM. It's not it is not our own thread. So threads locking on monitor. So here thread sleeps on monitor and threads wait for monitor. So yeah, this thread, as we saw, as you are explaining, that it means sleep or wait for an object, right? So this is what is happening, thread sleeping on monitor. So this pull thread 1, full thread 2, full thread 3, see all is coming under this thing, this thread on monitor. So and yeah, and there, if we come back to the monitor locking thread here, as you see this abstract, this threads on monitors, it will also give you the same picture, like why it is waits on monitor. So it is giving parking for wait. So in this program, it does not create any kind of problem in our program. So we are not generating any kind of deadlock kind of situation. It's just for you to understand the concept behind the different terminology, what is waiting on condition and what is waiting for monitor. Uh, uh, yep, so waiting for monitor here. So now I hope it is clear to you the concept and what we actually need to look at when doing this analysis. So in the next tutorial, I will give you some real world example with the help of this concept which we just learned here. So I hope you like this video, and let me know if you need some input further. Thank you.